We're going to look at some absolute value functions today, which are much like linear functions and kind of related to piecewise functions because they just have two lines that kind of meet at a vertex in the middle. That vertex is where you are going to want to start when you are making your graph. So to find the vertex, it's really the point that can give you the smallest output, and the smallest and absolute value function can be a 0. So if you can find the x value that makes the inside of your absolute value equal to 0, that is going to give you the location of your vertex. Then we're going to pick another x value, plug it in, get a y value out, probably a couple actually. And then since this is symmetric, we will reflect those points over the axis of symmetry and draw in our other half. So let's do a couple of graphs here. So we're going to start by finding our vertex. If you think about this one, our value that makes the inside of our absolute value function equal to 0 is just going to be 0. And then we need the y-coordinate of our vertex because that's only half of our point. So if I want my y value, I'll plug my x value back in. So I have -2 times the absolute value of 0, which is just 0. So my vertex is at 0, 0. Not super exciting on this one. Let's plot it. And then I like to draw in my axis of symmetry so that I remember that that is the center, and I'll reflect my points over to get both halves. So pick your favorite x value, pick one that's close to the vertex. I'm going to do 1 and 2. And then if I plug those in, I have -2 times the absolute value of 1 is 1, and that gets you -2 and -4. Don't forget to actually take your absolute values when you're doing your values of your points. I plot those, and then I'm going to count over to my axis of symmetry, go that same distance in the opposite direction. And then if I draw in my line, I've got my nice absolute value V shape. If it doesn't look like a V, double check your work. Domain and range. If you think about your domain, it's stretching left and right forever and ever. It's kind of got this point where it stops vertically, so my range is going to go from -infinity up to point with a y value of 0, and it's included, so it should be a square bracket. Let's do another one. If you are finding your vertex for this one, figuring out what value would make the inside of your absolute value function equal to 0 is going to give you -2 for the x-coordinate of your vertex. And then if you plug that back in, you're going to get absolute value of -2 plus 2, absolute value of 0 is 0. The y-coordinate of your vertex is not always 0, it just happened to be on these two. Alright, I'm going to sketch my vertex and axis of symmetry, and then I need a couple more points. Let's do -1 and 0. How about? Pick ones close to your vertex, like I said, because otherwise they might not fit on your graph. So if I plug those in, I'm going to end up with absolute value of 1 and absolute value of 2, 1 and 2, and reflect it over. Looks good to me. And then for your domain and range, domain is always going to be -infinity to infinity, and your range, it's got this point where it stops vertically, a low point, so smallest y value is 0, up towards infinity. So one thing you may have noticed about absolute value functions is they have this point where it's either their high point or their low point, your vertex of your absolute value function. It's kind of where it stops for its range. So these functions have what are called maximum or minimum values, and other functions have them too, not just absolute value functions. So if you think about the shape of your graph, functions that have maximum values have like highest points on their graph. Maximum value is the largest output you can get, so it's the y value that's the biggest of all of your points. So for example, on these two, you'd have a maximum value of 5 and a maximum value of -1. If your function is turned around the other direction and it's got like a low point, it has a minimum value. So for example, maybe that one's got a minimum of 5. We're going to graph a couple and decide whether or not our functions have a minimum or maximum value. So again, find your vertex, and your vertex on this one is going to have an x value of 1. Plug it back in. Make sure you follow order of operations. Inside your absolute value is 0. 2 times the absolute value is 0, and the 0 minus 4 is negative 4. So my vertex is at 1, negative 4. And then some more points. I'm going to do negative 1 and 0. So if I plug those in and evaluate, when I plug in negative 1, I'm going to get 4 minus 4 is 0, and when I plug in 0, I'm going to get, let's see, absolute value negative 1 is positive 1, negative 2. Plotting those and reflecting them over is going to give me my graph of my function. And then thinking about whether it's got a maximum or minimum value. If you look at it, it has a lowest y value that it reaches, so it's got a minimum y value there at your vertex, and it is a minimum value of negative 4. A lot of times we'll also go ahead and say where that happens at, so this one happens when our x value is equal to 1.